This lesson is about the fundamental theorem of algebra. Basically, the fundamental theorem of algebra says that the highest power of the polynomial matches the number of solutions. So if you have x squared, some polynomial with x squared, you get 2 solutions. And if you have x to the third power, you get 3 solutions. But it's how the solutions organize themselves. So let's look particularly at x to the fourth power. X to the fourth power, if you graph a polynomial with x to the fourth power, you could have some kind of polynomial that weaves across the x-axis 4 times. 1, 2, 3, 4. So you could get 4 real solutions. If you could also have some kind of polynomial with the highest power of x to the fourth power that weaves across the x-axis only twice. So that would be 2 real solutions and 2 imaginary solutions. But the point is you have to have 4 in all. And then you could have a polynomial with x to the fourth power with it never touching the x-axis. So that would be 4 imaginary solutions. So you could have 4 real, 2 imaginary, and of course 4 imaginary solutions. So basically you have to have 4 solutions. There's other cases where it could come down and touch a tangent. You have a repeat solution. It could curve through funny different ways. But the main idea is you have to have 4 solutions. One thing that's interesting about this is the imaginary solutions always travel in multiples of 2. So you can have 0 imaginary solutions, you could have 2 imaginary solutions, or you could have 4 imaginary solutions. They always go in pairs. So it's like you have to remember you have a pair of eyes. Okay, so these are eyes. So you always get a pair of eyes. Now if you think about it, imaginary solutions come from like taking the square root of a negative number. So if you have a situation like x squared is equal to -4, and you solve this, you take the square root of each side, you get x is equal to plus or minus 2i. So taking the square root of the negative number with the x squared gives you a plus or minus situation, plus or minus 2i. So you get 2 imaginary solutions that way. So the imaginary solutions always come with a plus minus. The other way you can get imaginary solutions, if you're solving a quadratic and you have like -8 plus or minus the square root of -11 over 2. Something like this. There's -11 there. Well, there's a plus and minus in front there, so it's going to be plus or minus with an I, so that you get 2 imaginary solutions there. So the imaginary solutions always travel in pairs. If you have x to the 5th power, you can have 5 real solutions. Okay, x to the 5th power, you could have 3 real solutions and 2 imaginary solutions. And if you have x to the 5th power as your highest power, you could have 1 real and 4 imaginary solutions. And those are the only situations that you can have. You can't have 3 imaginary solutions because imaginary solutions only go in 0, 2, 4, 6, 8, etc., multiples of 2. All right, so we're going to solve a 4th degree polynomial together. And we're going to use the calculator to help us with this. And I got myself a calculator here somewhere. Oh, here it is. And I'll do a little magic spinning here. Whee! All right. So we're going to type this in here. We're going to use the calculator to help us solve this. And so it's x to the 4th power, so we're looking for 4 solutions. So y equals, I'm going to type in x to the 4th power, push myself out, plus 2x to the 3rd power, with the caret key, push myself out, minus 4x squared, minus 7x minus 2. All right, so there's the 4th degree polynomial. So x to the 4th power, you could call it a quartic polynomial if you'd like to, but it's 4th degree for sure. Okay, I'm going to hit zoom and then number 6, zoom standard. And wait for it to graph. So I'm getting four real solutions. I got one there, there's two there, they're kind of hard to see, and then one right over here. So that appears that it crosses at 2. So I'm going to go to the trace key and type 2, enter, and sure enough, 20 is one of the roots of the equation. So x equals 2 is one of the solutions. And it appears that it crosses at -1. So I'm already in the trace mode, so I'm going to type -1, enter. And -1 is also a 0 of the function. See, it's -1, 0. So x is equal to -1. Oops, make it better, -1. There we go. So, I know these are two solutions that I found here. Now, there's another real solution there that appears to be around -1, -2, and some change, maybe around -2.6. And then this one here is around -0.5. So there's another solution there. And you could guess and check it. That was going to fuzz. There we go, right in here. So what we're going to do is we're going to divide these solutions out using synthetic division and then reduce this down to a quadratic so that we can solve it. So 2, I'm going to pick that first, do my synthetic division, 1, 2, -4, -7, -2. We drop, we multiply, we add, we multiply, we add, we multiply, we add, we multiply, and we get 0. So we know that this is a factor. That is a factor because it's a solution, because it gives me a 0. Now I'm going to synthetically divide again. -1, we drop down, we multiply, we add, we multiply, we add, we multiply, and we get 0 again. So the outside pieces multiply together to make the inside. So the divisors all multiplied and the quotient multiplied together will give you the dividend. So what does this really mean? Well, this 2 means x minus 2. This -1 means x plus 1. Remember, you always switch the sign with synthetic division. And then this is in the 4th position here. So it's remainder, number, x, and then x squared. So it's 1x squared plus 3x plus 1 is equal to 0. So this would be factored form. The original up here is standard form. It's all multiplied out. And this would be in factored form. Then we do 0 product proper super t. So we set each factor equal to 0. Now this part right here, I already know these two answers. I'm just trying to show you that this is how it factors. It factors into this linear factor times this linear factor times this quadratic. So we get x is equal to 2 and x is equal to -1. But I already knew that, and the calculator told me those were the answers before. I'm just showing you how this all works. So now I have to solve this quadratic. I could complete the square, but it's an odd number, so I'm going to use the quadratic formula. A is equal to 1, is equal to 1, B is equal to 3, and C is equal to 1. So here I go. X is equal to -b, so it'll be -3 plus or minus square root b squared, 3 squared minus 4 times A is 1 times C is 1, all over 2A, which is 2. So we get x is equal to -3 plus or minus square root over 2. Now that would be 9 minus 4, because 1 times 4 is 4. So it would be 9 minus 4 is 5. So there's the other two solutions. So I have a grand total of 4 solutions. I have 2, I have -2, and I have -3 plus or minus radical 5 over 2. Let's go ahead and get the decimal equivalents to these. So it's -3 plus radical 5 over 2 is equal to, not equal to, because I can't get an exact answer, approximately equal to, and then a number, and then x is equal to -3 minus radical 5 over 2, approximately equal to. So I'm going to get these two decimals and relate them back to the calculator that we saw earlier. So go to the home screen here. So you need to switch this over here because the light reflection's better, or the reflection's bad over there. So let's see, parentheses, -3 plus second radical 5, push myself out, close the parentheses, divided by 2. Okay, so it's negative 0.382. Negative 0.382, and that's the approximation. I rounded to 3 decimal places. And then I'm going to hit the up arrow, enter, and edit this so I don't have to retype it in again. Put in minus and 2.618. Negative 2.618. So didn't I say that one of the answers looked like it was negative 2.618? So we're going to go back to the trace key or graph and then trace, and then I'm going to type in negative 2.618, and it should take me right to that location right there. Enter. Yep, and it's really super close to 0 because that's in scientific notation. Then the other one was negative 0.382, enter, and it takes me right there to the other 0, and you can see that's really close to 0, but with the rounding part of it. Okay, so I use the calculator to find 2 of the solutions. I synthetically divided those 2 solutions out, and then I reduced it down to a quadratic, and I solved the quadratic to find the other 2 solutions. So there's 4 total solutions, and that would make sense for x to the 4th. But remember, x to the 4th has to have 4 solutions, but it could be 4 real like we just did, or it could be 2 real, 2 imaginary, or all 4 could be imaginary. Imaginary solutions always travel in pairs, and we need to have the highest power match the number of solutions. That's what the fundamental theorem of algebra says.